KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Now we are discussing integration topic, miscellaneous exercise. Next question, question number 38. Prove that integral 0 to pi by 4 2 tan cube x dx is equal to 1 minus log 2. Prove that integral 0 to pi by 4 2 tan cube x dx is equal to 1 minus log 2. Okay. Here first of all I will consider this as I. Okay, left hand side I is equal to 2 constant I will write outside, integral 0 to pi by 4 tan cube x I will write as tan square x into tan x. Tan square x into tan x. Further tan square x I will write it as secant square x minus 1. Tan cube x I will write as tan square into tan. Okay. Further tan square x as secant square x minus 1. Okay. Multiplying tan x inside and I will write it as two separate integrals. I is equal to 2 into integral 0 to pi by 4 secant square x into tan x dx minus integral 0 to pi by 4 tan x dx. Okay. Now I will mark this one as I1, this one as I2 and overall I as this one as 1. Okay. First of all I will calculate I1. What is I1? Integral 0 to pi by 4 secant square x dx. Okay. I1 is equal to integral 0 to pi by 4 tan x into secant square x dx. Okay. Now I will put, if you observe here, secant square x is a derivative of tan x, no? Derivative of tan x. I will put tan x is equal to t. Tan x is equal to t. Then secant square x dx is equal to dt. Okay. Now when x is equal to 0, lower limit is 0, upper limit is pi by 4. When x is equal to 0, tan 0 is 0, no? So t is equal to 0. Upper limit, when x is equal to pi by 4, tan pi by 4 is 1. So t is equal to 1. So lower limit is 0, upper limit is 1. Okay. So I1 is equal to tan x is t, secant square x dx is dt. So integral 0 to 1 t dt. So what is t integration? T square by 2, lower limit 0, upper limit 1. So by substituting upper limit 1 by 2 minus lower limit is anyhow 0. So I1 value is how much? 1 by 2. I1 value is 1 by 2. Now I2, what is I2? I2 is integral 0 to pi by 4 tan x dx. Okay. Now we have direct integration formula for integral 0 to pi integral tan x dx. Tan x integration is log mod secant x. Here lower limit is 0, upper limit is pi by 4. Okay. By applying upper limit in place of x pi by 4. Okay. So I2 is equal to log of secant pi by 4. Secant pi by 4 is root 2. Log of root 2 minus log of secant 0. Secant 0 is 1. So log 1 is 0. So this part is 0. So log of root 2. Log of root 2. Log of 2 power 1 by 2. Okay. 1 by 2 will write as quotient. So I2 is equal to how much? 1 by 2 log 2. I2 is equal to 1 by 2 log 2. Okay. So from 1 what we have? I is equal to 2 into I1 minus I2, no? So 2 into what is I1? 1 by 2 minus what is I2? 1 by 2 log 2. Now here 2 or else you take LCM. So what we have, 1 minus log 2 upon 2, 2 get cancel. So we will get final answer as I is equal to 1 minus log 2. That is what we have to prove. That is what we have to prove. Okay. Now here question is to prove that integral 0 to pi by 4 2 tan cube x is equal to 1 minus log 2. Okay. For, first of all, 2 outside, tan cube I'll write as tan square into tan. Okay. Further, tan square x as secant square x minus 1. So if we multiply tan x inside, we will get it as I is equal to 2 times of integral 0 to pi by 4 secant square x into tan x dx minus integral 0 to pi by 4 tan x dx. Okay. Now I'll consider this as I1, this as I2. I'll calculate I1 and I2 individually. First of all, what is I1? I1 is integral 0 to pi by 4 tan x into secant square x dx. Okay. Tan x into secant square x dx. I'll put tan x is equal to t. Secant square x dx is what? dt. Okay, lower limit when x is equal to 0, tan 0 is 0, so t is equal to 0. Upper limit when x equal to pi by 4, tan pi by 4 is 1, t equal to 1. So I1 reduces to integral 0 to 1, tan x is t, secant square x dx is dt. So I is equal to integral 0 to 1 t dt. T integration is t square by 2, lower limit 0, upper limit 1. By substituting upper limit in place of t, so 1 by 2 minus 0, that is 1 by 2. So I1 is equal to what? 1 by 2. What is I2? I2 is integral 0 to pi by 4 tan x dx. Integral tan x is log mod secant x. So log mod secant x, lower limit 0, upper limit pi by 4. Okay. So log mod secant pi by 4 minus log mod secant 0. Secant 0 is 1. So log 1 is 0. So this part is 0. So log of secant pi by 4. Secant pi by 4 is what? Root 2. So log root 2. Root 2 is nothing but 2 power 1 by 2. So 1 by 2 comes here. So I2 is equal to half log 2. So what is I from 1? I is 2 times of I1 minus I2. So 2 times of what is I1? 1 by 2 minus what is I2? Half log 2. Take LCM 2, 2 to get cancelled. We will get the answer as 1 minus log 2. That is what we have to prove. Okay, next question. Prove that integral 0 to 1 sin inverse x dx is equal to pi by 2 minus 1. Okay. Integral 0 to 1 sin inverse x dx is equal to pi by 2 minus 1. Now here actually we have only one function. What function is? One inverse trigonometric function, sin inverse x, which is not a directly integrable function. Whenever we have a single function which is not a directly integrable function, in such case you consider second function as 1. Okay. So taking sin inverse x as first function and 1 as second function and applying integration by parts. Okay. By applying integration by parts method. Integration by parts method, what is the formula? Okay. Integral first function into second function equal to first function into integral of second function minus integral of derivative of first function into integral of second function. So using that formula, so I is equal to what is first function? Sin inverse x. What is second function? 1. So first function sin inverse x into integral 1 dx minus integral of derivative of first function d by dx of sin inverse x into integral of 1 dx whole dx, lower limit 0, upper limit 1. So integral dx is what? X. So x into sin inverse x. So I is equal to x into sin inverse x minus integral of derivative of sin inverse x is what? 1 upon square root of 1 minus x square. 1 upon square root of 1 minus x square, and dx. Integral dx is what? X. So x dx. Now next step, observe carefully what we have here. I is equal to x sin inverse x minus integral of 1 upon square root of 1 minus x square into x dx. Okay. Now I'll write plus here and minus here. So what will get? Integral x sin inverse x plus integral minus x by square root of 1 minus x square dx. Okay. So I'll multiply with 2 and divide with 2. Multiply with 2 and divide with 2. What will get? X sin inverse x plus 1 by 2 into integral minus 2x upon square root of 1 minus x square dx. What is the advantage? What is the advantage is here I will write if you put 1 minus x square is equal to t, 1 minus x square equal to t, minus 2x dx is equal to dt. So entire numerator part dt, denominator part is root t. Also we have a formula, integral 1 by root t dt is 2 root t. Okay, 2 root t. So 2 into what is root t? Root of 1 minus x square. So this integration value is 2 into square root of 1 minus x square, lower limit as 0 and upper limit as 1. Observe carefully here, after differentiating sin inverse x, what we have 1 upon square root of 1 minus x square, integral 1 dx is x, this dx as it is, lower limit 0, upper limit 1. So here minus we have, I'll write plus, and minus here I will write. So x sin inverse x plus integral minus x upon square root of 1 minus x square into dx, multiply with 2 and divide with 2. So what we get, x sin inverse x plus 1 by 2 into integral minus 2x upon square root of 1 minus x square dx. Okay. Now here if you observe, if you consider 1 minus x square as t, then minus 2x dx as a dt. So numerator part is dt, denominator is root t. Now we have integral 1 by root t dt is 2 root t. So 2 into root of what is t? 1 minus x square. This integration part is 2 into square root of 1 minus x square. This 2 get cancelled. Okay. So what we have, I is equal to x sin inverse x into square root of 1 minus x square, okay, lower limit 0, upper limit 1. By substituting upper limit in place of x1, so 1 into sin inverse of 1 plus, here if you substitute 1 minus 1 0, okay, minus, by substituting lower limit 0, if you substitute 0 into something 0 plus 0 in bracket 0 plus square root of 1 minus 0, 1 minus 0 1, square root of 1 is 1. So what we have, sin inverse of 1 minus 1. Sin inverse of 1 is how much? Pi by 2. Pi by 2 minus 1. This one as it is. So pi by 2 minus 1 is the answer. Okay. That is what we have to prove. Okay. Here question is to prove integral 0 to 1 sin inverse x dx equal to pi by 2 minus 1. Here only one function which is not a directly integrable function. In such case, consider that function, given function as first function and unity as second function. Then by applying integration by parts method, first function into integral of second function minus integral of derivative of first function into integral of second function whole dx, lower limit 0, upper limit 1. So sin inverse x into integral dx is x, x sin inverse x minus integral of derivative of sin inverse x is 1 upon square root of 1 minus x square into integral 1 dx is x, okay, whole dx 0 to 1. So here what I will do, instead of minus I'll write plus 1 by 2 minus 2 here, okay. Now this is 1 minus x square if you consider as t, minus 2x as minus 2x dx is dt. So this will be of the form integral 1 by root t dt, that is 2 root t. 2 into what is root t? Root of 1 minus x square, lower limit 0, upper limit 1. By substituting upper limit, what we get, okay, what we get, sin inverse 1, okay, if I substitute 1 here it will be 0. If I substitute 0, lower limit minus of lower limit 0, and this is 1. Okay, so sin inverse of 1 is pi by 2 minus 1. Okay, that is the final answer. Next question, question number 41. 40 will discuss next one. Question number 41. Evaluate integral 1 upon e power x plus e power minus x dx. Evaluate integral 1 upon e power x plus e power minus x dx. Okay, now here e power minus x, what we can write, 1 by e power x. If you take LCM, e power x come to numerator. So what we get, if it e power minus x we can write as 1 by e power x. If you take LCM, okay, e power x in denominator, e power 2x plus 1 upon e power x in denominator. So this e power x comes to numerator. So I reduces to, I is equal to e power x dx upon e power 2x plus 1. Okay, now here I will put e power x is equal to t. Now e power x is equal to t, e power x dx is equal to what? Dt. So I is equal to integral numerator e power x dx is what? Dt upon, this is e power 2x, what we can write? E power x whole square, no? So t square plus 1. So I is equal to integral dt upon t square plus 1. So integral 1 upon t square plus 1 is tan inverse t plus c. What is t? E power x. So final answer is I is equal to tan inverse e power x plus c. Okay. Now here question is to evaluate integral 1 upon e power x plus e power minus x dx. This e power minus x I will write as 1 by e power x. Taking LCM, e power x comes to numerator. So we have I is equal to integral e power x dx upon e power 2x plus 1. By putting e power x is equal to t, e power x dx is equal to dt. So this given integration I reduces to integral e power x dx is dt, numerator dt, denominator is t square plus 1. So I is equal to tan inverse of t plus c. Okay, what is t? T is e power x, no? So I is equal to tan inverse of e power x plus c. Okay. Next question. Question number 42. Evaluate integral cos 2x upon sin x plus cos x whole square dx. Evaluate integral cos 2x upon sin x plus cos x whole square dx. Now cos 2x formula is cos square x minus sin square x. Okay, there are several formulas of cos 2x. Here I will write cos 2x as cos square x minus sin square x. So numerator is of the form a minus b whole square. So a minus b whole square, what we can write, a plus b into a minus b. Okay, so cos square x minus sin square x is cos x plus sin x into cos x minus sin x. So denominator sin x plus cos x whole square. So sin x plus cos x into sin x plus cos x. What is the advantage? Sin x plus cos x, sin x plus cos x cancel. So I is equal to numerator is cos x minus sin x dx, denominator is sin x plus cos x. Okay, I will put denominator equal to t. Put sin x plus cos x equal to t, sin x derivative cos x plus cos x derivative minus sin x, dx is equal to dt. So entire numerator part is what? Dt, denominator is t. So I reduce this to integral 1 by t dt. Okay, integral 1 by t dt. Integral 1 by t is what? Log mod t. So log mod t plus c. What is t? Sin x plus cos x. So I is equal to log mod sin x plus cos x plus c. Okay, that is the final answer. Now here question is to evaluate integral cos 2x upon sin x plus cos x whole square dx. Cos 2x I will write as cos square x minus sin square x. Okay. Now further cos square minus sin square you can write as cos plus sin into cos minus sin. Denominator sin plus cos whole square you can write as sin plus cos into sin plus cos. So numerator denominator sin plus cos cancel, sin plus cos cancel. So numerator is cos x minus sin x dx, denominator is sin x plus cos x. Okay, I will put sin x plus cos x is equal to t. Okay, its derivative sin x derivative cos x plus cos x derivative minus sin x, cos x minus sin x dx is equal to dt. So entire numerator part is what? Dt. So I is equal to integral 1 by t dt. Okay, I is equal to integral 1 by t dt. Integral 1 by t is what? Log mod t. So log mod t plus c. So I is equal to log mod, what is t? Sin x plus cos x plus c. That is the final answer. Okay, next question. Question number 43. If f of a plus b minus x is equal to f of x, then find integral a to b x into f of x dx. Okay. Here we have to find what is given here, f of a plus b minus x is equal to f of x. We have to find integral a to b x into f of x dx. Okay. Now if we consider this as I is equal to integral a to b x into f of x dx. Okay. Now we know this formula or property, integral a to b f of x dx is equal to what we can write, integral a to b lower limit plus upper limit minus x dx. Means replace variable by lower limit plus upper limit minus x. Okay. Now using this property, now here if you replace x by a plus b minus x, what we get, I is equal to integral a to b a plus b minus x into f of a plus b minus x dx. Okay. Now I will multiply a plus b minus x here and here. Now if you write it as separate integrals, you get I is equal to a plus b into integral a to b f of a plus b minus x, okay, minus integral a to b x into f of a plus b minus x dx. Okay. But what is given is f of a plus b minus x is equal to f of x. So this becomes what? F of x dx. This is also f of x dx. So I reduces to a plus b integral a to b f of x dx minus integral a to b x into f of x dx. Now integral a to b x into f of x dx is nothing but I only know from 1. So if you write minus I this side, it will be plus I plus I. 2I is equal to a plus b into integral a to b f of x dx. If you cross multiply to this side, so what we get, I is equal to a plus b by 2 integral a to b f of x dx. Okay. Next question. The value of integral 0 to 1 tan inverse of 2x minus 1 upon 1 plus x minus x square dx. Evaluate, find the value of integral 0 to 1 tan inverse of 2x minus 1 upon 1 plus x minus x square dx. Now observe here, I will write I is equal to integral 0 to 1 tan inverse of 2x minus 1. 2x minus 1 I will write as x minus of 1 minus x. X minus of 1 minus x. So minus of minus plus x only, no, x plus x 2x minus 1. Okay, denominator I'll take x common. So x into 1 minus x. Now I is equal to integral 0 to 1 tan inverse of x minus of 1 minus x upon 1 plus x into 1 minus x. If you observe, it is of the form tan inverse of a minus b upon 1 plus ab. It is of the form tan inverse of a minus b upon 1 plus ab. So tan inverse of a minus b upon 1 plus ab is tan inverse a minus tan inverse b. So I is equal to integral 0 to 1 tan inverse x minus tan inverse 1 minus x dx. Okay, I'll mark this one as 1. Okay, we have a property that integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. Replace variable by upper limit minus x. Here what is upper limit? 1. So replace x by 1 minus x here. So what we get? I is equal to integral 0 to 1 tan inverse of, in place of x if you write 1 minus x, minus tan inverse of 1 minus of, in place of x if you write 1 minus x. Now here 1 minus 1 cancel, minus of minus plus x. So what we have? I is equal to integral 0 to 1 tan inverse of 1 minus x minus tan inverse x dx. Okay, now by adding 1 and 2, what we have left hand side 2i is equal to integral 0 to 1 tan inverse x minus tan inverse of 1 minus x plus tan inverse 1 minus x minus tan inverse of x. By adding all this, so tan inverse x minus tan inverse x get cancelled, minus tan inverse 1 minus x plus tan inverse 1 minus x can get cancelled. So what we have here? This is 0. So 2i equal to 0 means integration value is 0. Okay, now here tan inverse of 2x minus 1 upon 1 plus x minus x square. So here 2x minus 1 I'll write as x minus of 1 minus x upon 1 plus x minus x square. I'll take x common here in these two terms, x into 1 minus x. Now it is of the form tan inverse of a minus b upon 1 plus ab. This is nothing but tan inverse a minus tan inverse b form. So I is equal to integral 0 to 1 tan inverse x minus tan inverse 1 minus x dx. Okay, by applying the property that integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx, nothing but replace variable by upper limit minus variable. We have I is equal to integral 0 to 1 tan inverse of x is replaced by 1 minus x minus tan inverse of 1 minus x is replaced by 1 minus x. Here 1 minus 1 get cancelled. So it is reduces to integral 0 to 1 tan inverse 1 minus x minus tan inverse x dx. This is 2. Now 1 plus 2, left hand side is 2i is equal to integral 0 to 1. Okay, right hand side if you add these 4, tan inverse x minus tan inverse 1 minus x plus tan inverse 1 minus x minus tan inverse x. Okay, so if you add all this, okay, what we have? Tan inverse x minus tan inverse x get cancelled, tan inverse 1 minus x minus tan inverse 1 minus x get cancelled. So 2i is equal to 0, so I is equal to 0. Okay, next question. Now evaluate integral 0 to 1 2 minus e power 2 minus 3x dx as a limit of a sum. Actually this part for this year it is eliminated. Okay, this type of question, a limit of a sum. Okay, this method is eliminated this year. Okay, anyhow we'll discuss the question. So question is to evaluate integral 0 to 1 e power 2 minus 3x dx as a limit of sum. Okay, now we have a formula, limit of a sum, integral a to b f of x dx is equal to b minus a into limit n approaches to infinity 1 by n f of a plus f of a plus h, f of a plus 2h and so on up to f of a plus n minus 1 into h, where h is b minus a upon n. Okay, now here in the given question, what is f of x? E power 2 minus 3x. What is lower limit? Lower limit is 0, a equal to 0. What is upper limit? B is equal to 1. What is h? H is equal to b minus a upon n, nothing but h is equal to 1 by n. Okay, now what is f of 0 ma? F of 0 nothing but e power 2. F of 0 plus h, a plus h is nothing but f of 0 plus h, nothing but f of h. F of h is nothing but f of 1 by n, nothing but e power 2 minus 3 by n. Okay, now using this formula, what we have? Integral 0 to 1 e power 2 minus 3x dx is equal to b minus a 1 minus 0 into limit n approaches to infinity 1 by n f of 0 plus f of 0 plus h, f of 0 plus 2h and so on up to f of 0 plus n minus 1 into h. Okay, so it is nothing but limit n approaches to infinity 1 by n f of 0 plus f of h. F of h is nothing but f of 1 by n plus f of 2 by n plus f of 3 by n and so on up to f of n minus 1 by n. So here last term is what? F of n minus 1 into h. H is nothing but 1 by n. So f of n minus 1 by n. Okay. So limit n approaches to infinity 1 by n. F of 0 is how much? E power 2 plus f of 1 by n is how much? E power 2 minus 3 by n plus f of 2 by n is how much? E power 2 minus 6 by n and so on up to f of n minus 1 by n is e power 2 minus 3 into n minus 1 by n. Okay. Now if you observe, in each term we have e power 2. So I'll take e power 2 common. So e power 2 into limit n approaches to infinity 1 by n into 1 plus e power minus 3 by n plus e power minus 6 by n we can write as e power minus 3 by n whole square plus next term e power minus 3 by n whole cube and so on up to last term e power minus 3 by n whole power n minus 1. Now if you observe, all these are sum of n terms of a geometric progression. Sum of n terms of a geometric progression with first term as 1, common ratio as e power minus 3 by n. Okay. Now sum of n terms of a geometric progression. What is Sn? Sn is equal to a into r power n minus 1 by r. So using this formula, a value is 1 and r value is e power minus 3 by n. So we have e square into limit n approaches to infinity 1 by n into a value 1, r power n nothing but e power minus 3 by n whole power n minus 1 upon r minus 1 nothing but e power minus 3 by n minus 1. Now here n get cancelled. So what we have? E power 2 limit n approaches to infinity 1 by n into e power minus 3 minus 1. Okay. But that is constant. I'll write outside. So e square into limit n approaches to infinity e power minus 3 minus 1 into 1 by n upon e power minus 3 by n minus 1. Okay. Now here what I will do is I'll multiply with minus 3 and divide with minus 3. Multiply with minus 3 and divide with minus 3. Okay. So if you multiply e square inside, so what we get? E power minus 1 minus e square by minus 3. E power minus 1 minus e square by minus 3. If you multiply with minus, here by multiplying with minus, what will get? E power minus 2 minus e power minus 1 by 3. Okay. Now this integral, this limit value is 1. Explanation is given here as n approaches to infinity 1 by n approaches to 0 minus 3 by n is also approaches to 0, let it be t. So what we have? Limit t approaches to 0 t by e power t minus 1, that you can write as limit t approaches to 0 1 by e power t minus 1 by t, but this value is 1. Okay. What we know? Limit x approaches to 0 e power x minus 1 by x value is 1. So this limit value is 1. Okay. Here question is to evaluate integral 0 to 1 e power 2 minus 3x dx as limit of a sum. We have a formula integral a to b f of x dx equal to b minus a into limit n approaches to infinity 1 by n f of a plus f of a plus h plus f of a plus 2h and so on up to f of a plus n minus 1 into h. Okay, where h is equal to b minus a upon n. Now here for the given question f of x is e power 2 minus 3x, lower limit a equal to 0, upper limit b equal to 1, h is equal to 1 by n. Okay. Now f of 0 is nothing but e square, f of 0 plus h nothing but f of h, nothing but f of 1 by n is equal to e power 2 minus 3 by n. Okay. Using this formula for this question we will get limit n approaches to infinity 1 by n f of 0 plus f of 1 by n plus f of 2 by n and so on up to f of n minus 1 by n. Okay. Now f of 0 is e power 2 plus f of 1 by n is e power 2 minus 3 by n plus f of 2 by n is e power 2 minus 6 by n and so on up to f of n minus 1 by n is e power 2 minus 3 into n minus 1 by n. So e power 2 common, e power 2 common, limit n approaches to infinity 1 by n 1 plus e power minus 3 by n plus e power minus 3 by n whole square plus e power minus 3 by n whole cube plus and so on up to e power minus 3 by n whole power n minus 1. This is sum of n terms of a geometric progression with first term as 1 and common ratio as e power minus 3 by n. Okay. Sum of n terms of a geometric progression is a into r power n minus 1 by r minus 1. So using this formula we will get e square into limit n approaches to infinity 1 by n e power minus 3 by n whole power n minus 1 upon e power minus 3 by n minus 1. Okay. Here n get cancelled. So e power minus 3 minus 1, that is constant, we will write outside, 1 by n inside. So what we have? e power 2 into limit n approaches to infinity e power minus 3 minus 1 into 1 by n upon e power minus 3 by n minus 1. Okay, multiplying and dividing with minus 3. Okay, so this part is how much? This part, if you multiply e power 2 inside, e power minus 1 minus e square upon minus 3, nothing but e square minus e power minus 1 upon 3. Okay, this limit value is 1. This limit value is 1. Since as n approaches to infinity, 1 by n approaches to 0, minus 3 by n approaches to 0. Now if you consider this as t, now this limit is of the form limit t approaches to 0, t upon e power t minus 1, which you can write as limit t approaches to 0, 1 upon e power t minus 1 upon t. This value is 1. So overall this limit value is 1. So final answer is e square minus e power minus 1 upon 3. Okay. Now with this we completed this entire integral chapter, very lengthy chapter. Okay. After this we'll start applications of integration.